If humans were born and raised on Mars, they would develop taller, leaner bodies with reduced muscle and bone density due to the planet's low gravity. Their lungs would become highly efficient at extracting oxygen from the thin atmosphere, and their skin would darken to protect against radiation. In contrast, surviving on Venus would require a shorter, sturdier body to withstand extreme atmospheric pressure, thick, reflective skin to endure intense heat and acid rain, and reliance on oxygen tanks due to the toxic atmosphere. These adaptations highlight the significant physiological changes needed for human survival on other planets. If you were born and raised on Mars, your body would look very different. Mars might be the best candidate for humanity's future space settlement, but regarding gravity, breathable atmosphere, and liquid water, it is not a place you could survive in your current state. If you tried to walk on the red planet without a spacesuit, you would suffocate, swell, and die of extreme radiation poisoning within minutes. That wouldn't be pretty. To survive Mars's harsh environment, your body would have to adapt significantly. You'd have to be taller and leaner. Martian gravity is only about 38% of Earth's gravitational pull, meaning you wouldn't need much muscle power to walk around. You'd lose bone and muscle density, but that's okay. Your taller frame would use less energy, which is good news, because food on Mars would be pretty scarce. Additionally, being taller would help you see further. Speaking of sight, your eyes would need to change. Mars is known for its dust storms, and it's not as sunny there as it is on Earth. Your eyes would have to adapt to these conditions, enabling you to see better in low light. Your tears would also become stickier to protect you from all the dust and debris. Mars barely has an atmosphere, which means two significant changes for your body. First, your lungs would need to become super lungs capable of extracting trace amounts of oxygen from the Martian atmosphere. Second, your skin would turn dark brown to protect you from harmful solar radiation. Without a dense atmosphere, Mars gets bathed in radiation and experiences extreme cold. The temperature on Mars ranges from a comfortable 20 degrees to a freezing cold, 153 degrees. Your dark skin would help absorb more heat to keep you warm during chilly periods. Now consider if you were born on a much hotter planet than Mars. Welcome to Venus. Venus has a dense atmosphere that traps the sun's heat, turning the planet into a furnace. It's so hot on Venus that if you walked outside without a spacesuit, you'd be instantly incinerated. You'd also be crushed under the extreme atmospheric pressure, which is 92 times higher than Earth's. Evolving to live on this hellish world would require a short and sturdy body with thick, silver skin. Your skin would need to reflect intense heat and radiation and neutralize sulfuric acid. Venus's atmosphere is thick with carbon dioxide and clouds of sulfuric acid droplets, so you'd need to withstand Venusian acid rain. Your shorter, more compact body would provide the necessary support to withstand the extreme atmospheric pressure. However, you still couldn't breathe the toxic Venusian atmosphere and would need to rely on oxygen tanks. An active lifestyle on Venus would be impossible because you'd need to conserve energy and whatever oxygen you could get. You'd pretty much be stuck in your living quarters the entire time. Living on Venus would be extremely difficult, even with an extremely sturdy skeleton. In summary, surviving on Mars would require significant physiological changes, such as increased height, reduced muscle mass, enhanced lung capacity, and darker skin. On Venus, survival would necessitate a short and sturdy body, thick, reflective skin, and reliance on oxygen tanks. These adaptations highlight the extreme conditions on other planets and the need for advanced research and technology to make human life possible beyond Earth. Exploring adaptations for human survival on other planets. Mercury. Mercury, being closer to the Sun than Venus, presents unique challenges for potential human settlers. Unlike Venus and Mars, Mercury's lack of atmosphere results in extreme temperature variations. Daytime temperatures can soar to 427 degrees Celsius, while nighttime temperatures plummet to 179 degrees Celsius. Each night on Mercury spans almost 3 Earth months, necessitating significant adaptations for human survival. To withstand these conditions, humans would need a thermal insulation layer under their skin, providing both heat reflection during the day and heat retention at night. This adaptation would give a metallic appearance similar to what would be necessary on Venus. Additionally, a sturdy and stocky body with a layer of fat would help maintain warmth during the long, cold nights, while longer and more flexible limbs would facilitate movement. Due to Mercury's gravity being only 38% of Earth's, muscle mass would decrease, but radiation-resistant cells would be essential due to the planet's proximity to the Sun and lack of atmospheric protection. Breathing on Mercury would be impossible without significant changes. Humans might evolve smaller lungs, capable of storing oxygen, or develop a specialized organ to produce oxygen from ingested minerals, akin to plant photosynthesis. Jupiter. Jupiter presents a vastly different environment. As a gas giant, it lacks a solid surface consisting mainly of hydrogen and helium. Humans attempting to live here would glide through these gaseous clouds. The planet's intense pressure would necessitate a short and compact body structure, and strong muscles would be vital to withstand the gravitational forces. Dark skin would provide some protection against Jupiter's radiation. To navigate Jupiter's thick atmosphere, the human body would need to contain lighter-than-air gases. However, the absence of oxygen in Jupiter's atmosphere poses a significant challenge, making survival without evolving the ability to breathe hydrogen or helium impossible. Saturn. Similar to Jupiter, Saturn's gaseous nature and high atmospheric pressure would demand adaptations like a compact body and radiation-resistant skin. Specialized organs might evolve to synthesize breathable oxygen from water vapor or ammonia, offering a slight advantage over Jupiter. Uranus. On Uranus, humans would need a short, blue-pigmented body for protection against cosmic radiation. Thick skin with heat retention capabilities would be crucial, as Uranus is one of the coldest planets, with temperatures dropping to 224 degrees. Like Jupiter and Saturn, Uranus lacks oxygen and a solid surface, further complicating human survival. Neptune. Neptune presents conditions similar to Uranus, minus the hydrogen sulfide clouds that give Uranus its rotten egg smell. Slightly warmer, Neptune still remains inhospitable for human life, even with evolved adaptations. Titan. One of Saturn's moons, Titan, may offer a more feasible option for human settlement. However, that exploration is a story for another time. In summary, the extreme environments of Mercury, Jupiter, Saturn, Uranus, and Neptune would require significant physiological changes for humans to survive, from thermal insulation and radiation resistance to specialized respiratory adaptations. Each planet presents unique challenges that highlight the need for advanced scientific research and technology to make interplanetary human life possible. Studying how humans can adapt to harsh environments on other planets opens up new possibilities for biology and medicine, helping us better understand the limits and potential of the human body. The challenges of living on other planets drive the development of advanced technology, not only in space exploration, but also applicable on Earth, such as in medical technology and new materials. Imagining and researching settlement on other planets encourages humanity to expand its vision of the future, sparking curiosity and a spirit of exploration, contributing to the continuous progress of humankind.
Welcome to live coverage of the celestial event of the year, the total solar eclipse.
A total solar eclipse is one of the most impressive sights in our universe. As rare as they are, they don't just happen on Earth. On some planets, they occur every single day. Today, we're going to take you throughout the solar system to experience what a solar eclipse is like on different planets. From a triple solar eclipse on Jupiter to the weirdness of a Mars solar eclipse. Join us as we take you on a journey to experience every solar eclipse in our solar system. But first, what is a solar eclipse? Well, a total solar eclipse on Earth happens when our moon passes between us and the sun, blocking sunlight for several minutes. These events happen on Earth every 18 months or so, but we rarely get to see them. That's because a lot of the time these solar eclipses happen somewhere out over the ocean. On April 8, 2024, most of North America will be able to see a total solar eclipse. Scientists estimate the next time this will happen will be in the year 2033. But you know what a solar eclipse looks like on Earth? What does it look like on other planets? Let's start with Jupiter. Jupiter, the largest planet in our solar system, has 95 moons. But that only tells part of the story. Since Jupiter has such a big gravitational pull, it's got thousands of different kinds of asteroids, celestial bodies, and space debris orbiting around it. Despite having 95 moons, only 4 of them are known to cause a total solar eclipse on the planet. Io, Ganymede, Europa, and Callisto. Each provides a unique solar eclipse experience. One of my favorites is Io. It's 1/800 kilometers in diameter, making it the 3rd largest moon of Jupiter. And for reference, that's about 5% bigger than our moon. NASA has captured some incredible images of what a solar eclipse looks like with Io. That shadow you see there is being cast by the sun onto the planet. Another incredibly cool aspect of this solar eclipse is that Io is the most volcanically active celestial body in the solar system. Because of all these volcanoes, you'd look up at the solar eclipse and see a sparkly ball of fire blocking out the sun. This amazing sight would last around 13 minutes. Solar eclipses found on Earth can last from a few seconds to about 7 minutes, and this is due to the proximity of the moon to our sun and the speed at which the moon travels. But what about a triple solar eclipse? Yeah, that's right. Now, this only happens once or twice every 10 years, but at times Io, Callisto, and Ganymede will all line up and block out the sun, creating this incredibly cool effect. Now watch as these planets create some mesmerizing shadows on Jupiter's surface. Wait for it. Wait for it. Nothing's happening. Oh, right. Well, that's because Mercury and Venus don't have any moons to block out the sun. But why? Well, Mercury is moonless because of how close it is to the sun. Since it's a smaller planet, its gravity is too weak to hold on to other celestial bodies. They either crash into the planet or are swallowed up by the sun. Now, Venus is a bit of a different story. Billions of years ago, the planet may have had a moon, but then millions of years later, it was impacted by another massive rock hurtling through space. This caused the planet to change its orbital direction, causing its moon to crash directly into the planet. Maybe one day a big enough asteroid will swing by and create a brief solar eclipse for Venus and Mercury, but for now they'll just have to imagine what a solar eclipse is like. Luckily, you won't have to. Let's swing over to our other planets. Mars. Welcome to Mars. The red planet has the opportunity to showcase multiple solar eclipses because it has two moons, Deimos and Phobos. But there's a bit of an issue. These solar eclipses are quite different from what we might see on Earth, and that's because they only provide a partial solar eclipse. These little guys are practically glorified asteroids. Phobos has a diameter of 22.2 kilometers, and Deimos is even smaller with a diameter of 12.6 kilometers. Now, because of their tiny size and their distance from the Sun and Mars, they can only block out parts of the Sun. But despite this, the sights are still incredibly mesmerizing. Now, what if we looked at the eclipse from the viewpoint of one of the moons? Well, from this epic viewpoint, you'd see Mars eclipse the moon, creating a full solar eclipse. The coolest part? Well, depending on the time of year, this could happen every day. Saturn. Now, Saturn's got dozens of moons, approximately 146 of them. Some of its moons are bigger than Mercury. Now, similar to some of the other planets, NASA has been able to capture some breathtaking imagery of eclipses happening on the planet. But now, we're going to show it to you in a way that's never been done before. Now, just like with Mars, depending on your vantage point, you could experience multiple solar eclipses a day depending on the season and which moon you decide to camp out on. Uranus. Now, Uranus has about 28 moons. Just 5 or so are big enough to provide a full solar eclipse. The only problem? They're incredibly rare. Yeah, since the planet has an 84-year orbit around the Sun, a solar eclipse happens only once every 42 years. The reason for this is that Uranus is tilted on its side. The extreme tilt results in strange patterns of sunlight on the planet. Not to mention, it causes Uranus's moons to float along its equator. Once every 42 years, Uranus's poles happen to line up and face the Sun. Once this happens, then the moons are able to align in a way that they can pass in front of the Sun, causing a total solar eclipse. Neptune. Out of Neptune's 14 moons, half of them are able to produce a solar eclipse. So, the view from this planet must be pretty incredible, right? Unfortunately, what you get here is less than stellar. Neptune is so far away from the Sun that instead of the blistering star that we know from our perspective on Earth, the Sun there is just a small little sparkle in the sky. You see all these stars while looking up at the night sky here on Earth? Well, that's what our Sun would look like on Neptune. It gets 1/1900th of the sunlight we get back at home. Now, because of this, when a solar eclipse does happen, it's not that noticeable, and it only lasts a few seconds. Pluto. Now, it's not technically a planet anymore, but we've got to give some love to the littlest guy in our solar system. Pluto has a particularly interesting solar eclipse that happens every 120 years. Pluto takes turns eclipsing the Sun with its largest moon, Charon, roughly every 6.5 Earth days. Another twist? Well, since Pluto only shows half the planet to the moon, only half the planet experiences the eclipse. So, there you go. This is what happens when moons and other celestial bodies cover up the sun. Hey, have you ever thought about what would happen if the sun suddenly produced a solar flare headed right for Earth? Well, that sounds like a story for another. How long can you survive on the planets of the solar system? Our solar system, a collection of the sun, 8 planets, and countless other celestial bodies, has always been a source of endless inspiration for both science and fiction. While life on Earth averages about 80 years, survival on other planets is vastly shorter, often only a few seconds. What creates this stark contrast? This article provides a detailed analysis of human survival time on each planet in the solar system, from the thermonuclear impacts of the sun to the immense pressure forces on gas giants. Earth, the home of life. Earth is the only celestial body in the solar system where humans can survive long-term without the aid of advanced technology. As the third planet from the sun, it boasts an oxygen-rich atmosphere and essential life-supporting elements like water, fertile soil, and a relatively stable temperature environment. Living conditions on Earth. Earth's protective atmosphere consists of approximately 78% nitrogen, 21% oxygen, and 1% other gases such as argon and carbon dioxide. This layer not only provides the necessary oxygen for respiration, but also shields us from harmful solar radiation and minor meteoroids. The diverse climates, from tropical to polar regions, offer a variety of living conditions and support a wide range of biodiversity. Approximately 71% of Earth's surface is covered by water, mostly in oceans. Water is crucial for life, supporting biochemical processes within living organisms. On average, humans live about 80 years, with some people living longer in blue zones, areas known for significantly higher longevity due to healthy lifestyles and optimal nutrition. These regions include Okinawa, Japan, Sardinia, Italy, and Loma Linda, California, USA. The Sun, a gigantic energy sphere. Composition primarily hydrogen, 74%, and helium, 24%, with heavier elements making up about 2%. Nuclear fusion in the core converts hydrogen into helium, releasing massive amounts of energy. Survival, approaching the sun, would result in immediate vaporization due to the extreme temperature and intense radiation. As Neil deGrasse Tyson explains, you would be vaporized immediately. Survival time, less than 1 second. Mercury, the extreme planet temperature. Atmosphere, very thin, primarily composed of helium and hydrogen, insufficient to protect from solar radiation or maintain stable temperatures. The huge temperature differences on Mercury's surface create a very limited survival environment. If you could stand on the boundary between day and night and hold your breath, you might survive for a very short time, about 2 minutes. Venus, the hellish planet. Hotter than Mercury despite being further from the sun. This is due to an extreme greenhouse effect caused by the thick CO2 atmosphere. Atmosphere extremely thick, mostly carbon dioxide with sulfuric acid clouds. Atmospheric pressure is about 92 times that of Earth. The intense pressure and extreme temperatures make Venus a deadly environment for humans. Survival time, less than 1 second. Mars, the red planet. The thin atmosphere cannot retain heat, resulting in significant temperature fluctuations between day and night. Atmosphere, mainly carbon dioxide, 95%, with some nitrogen and argon. Atmospheric pressure is only about 0.6% of Earth's. Although extremely cold, the thin air lessens the feeling of cold. With warm clothing and protective gear, survival would only be possible for a brief period. About 2 minutes. Jupiter, the gas giant composition, primarily hydrogen and helium, with a large rocky or metallic core. Atmosphere, thick and turbulent, with increasing pressure at greater depths. Massive storms like the Great Red Spot could engulf Earth. On Jupiter, you would continuously fall into the dense atmosphere and eventually be crushed by immense pressure. Survival time, less than 1 second. Saturn, the planet with rings. Similar to Jupiter, with hydrogen and helium predominating, Saturn's rings consist mainly of ice and dust. Atmosphere, thick, with layers of ammonia, water, and methane clouds. As with Jupiter, you would be crushed by the atmospheric pressure upon falling into Saturn's atmosphere. The rings do not offer any stable surface to stand on. Survival time, less than 1 second. Uranus, the ice giant, one of the coldest planets. Atmosphere, mostly hydrogen, helium, and a significant amount of methane, giving it its blue color. The freezing temperatures and high pressure in Uranus's atmosphere would crush and freeze you. Survival time, less than 1 second. Neptune, the stormy planet. The atmosphere is frigid with fierce storms. Composition primarily hydrogen, helium, and methane. Large storms on this planet have wind speeds up to 300 menopy, to 100 kilometers. Similar to Uranus, you would be crushed and frozen by the extreme pressure and low temperatures. Survival time, less than 1 second. Pluto, the dwarf planet, icy surface primarily composed of nitrogen with a thin atmosphere. The extremely low temperatures and thin atmosphere of Pluto make it inhospitable. Survival time, less than 1 second. The solar system, with its diverse planetary characteristics, highlights the uniqueness of Earth in supporting life. From extreme temperatures to immense pressures, nowhere else in the solar system offers conditions favorable for long-term human survival like Earth does. Understanding these harsh environments not only underscores the fragility of life, but also fuels efforts to explore and potentially settle in space in the future. The analysis of survival time on each planet in the solar system not only provides scientific insight into the extreme environments beyond Earth, but also conveys profound meanings regarding Earth's unique position, the importance of technology and space exploration, and the challenges of extraterrestrial settlement. Primarily, Earth's ideal conditions, an oxygen-rich atmosphere, stable temperatures, and abundant water, are essential for life, allowing humans to live an average of about 80 years. This starkly contrasts with other planets, where survival time is mere seconds due to extreme conditions like Mercury's and Venus's scorching temperatures or the immense pressure and violent storms on gas giants like Jupiter and Saturn. These conditions make survival on other planets impossible without advanced protective and life-supporting technologies. Furthermore, the analysis underscores the necessity of space technology, including spacesuits and complex life support systems for ensuring the safety of astronauts. Surviving in space without these protective technologies would result in immediate, catastrophic consequences. This suggests that before considering settlement on other planets like Mars, a plan pursued by visionaries like Elon Musk, there must be the development of effective safety measures and technologies. Currently, the environmental conditions on any other planet do not support long-term life without complex protective measures, highlighting the importance of thorough and safe preparation. This analysis also emphasizes Earth's unique place in the solar system. Elements such as the protective atmosphere and abundant water not only make Earth the only place for long-term survival, but also remind us of the fragility and preciousness of this environment. This understanding promotes awareness of the need to protect Earth's environment and resources to ensure the survival of future generations. Finally, the information about the harsh conditions on other planets also drives the search for extraterrestrial life in more habitable environments. Research into the viability of life in harsh conditions can expand our understanding of astrobiology and the possibility of life beyond Earth. Simultaneously, these descriptions serve as a warning about the potential dangers of space travel. Exploring and settling on other celestial bodies require careful preparation and advanced protective technologies to avoid fatal risks from extreme environmental conditions. That's all the information that we have for you today. Don't forget to give us a thumbs up if you enjoyed today's episode, subscribe if you haven't already, and hit the bell so you never miss out on future episodes. And be sure to also tell us what you think about today's content. Everyone's support motivates us to continue delivering quality content and to always improve. As always, thanks for watching, and we will see you next time.